go through the answers for this so you guys can see it. We're doing answer for number 2, which is on that 2017 organic exam. So if you're not doing organic, you can ignore me. If you are, you should be listening and checking your work that you've done. Cool. So these are the answers for the naming practice. Be mindful that this one here was not an aldehyde, it was a tertiary alcohol, so you have 2-methylpropane-2-ol. Are there anyone on this list that you guys want me to go through and explain the name? You guys okay? All right, you need to get 3 out of those 5 correct, and this only was an achieve point. All right. Next thing then was your identification test question. I'm just going to zoom out so you guys can see it. Each one you should be able to identify. If you are finding you can't identify it in some way, it might just be a solubility issue, and then that's how you distinguish them. Or you might have done something wrong and misidentified something. So, first thing to think about also is how could you do this in a sequence of events so that way you can kind of eliminate what things are and do things more efficiently. The first thing you could do is add the moist litmus paper. The aminomethane is an amine, so that'll turn blue. The ethanol chloride, because it's moist, it will react with the water and will form a carboxylic acid, and so that's going to turn red, and then none of the others will change color. The bromine water is, again, something that we can use to help us determine things. It will find the alkene. So basically, the pent-1-ene will decolorize. Remember, make sure you're stating your color observations, because that's part of the points with that. With the acid chloride, it's going to react violently, but that just has to do with the fact that there's water in there. So whenever we see water, we're going to expect the acid chloride to do a violent reaction. And then the last thing you're doing is the oxidant, which is your dichromate. With this one, the ethanol is the only one that will react. It's the only one worth testing because that's the one that is going to oxidize. It's an alcohol. So this is what I'm saying. You can use process of elimination so you don't have to use things for other things, and that's kind of showing efficiency. The 2-methylpropane-2-ol will not react because it's a tertiary alcohol. It cannot get further oxidized because there's no way to put a double bond there. When it comes to this question, I'm just going to move over and go to the document camera real quickly because I think it's good to kind of do both when I'm talking to you guys. Let me just get that clear. There we go. With this, I would suggest a very good idea to help you with the identification question, and this is what I always tell you guys, is to annotate. Annotating helps you kind of recall and pull that information. With organic chemistry, there's no point in doing these exams unless you've memorized all the reactions, because you need that information to know what things are going to be doing. So, since they're asking you from A through E, annotate what this is. So that's an acid chloride. That is a primary alcohol. That is a tertiary alcohol. That is an amine. And that is an alkene. So from just doing that as an annotation and identification, it helps me pull that information of what I know about each one of these guys and what I would expect it to happen. I can then overlap that on what they have given me reagent-wise. So they've given me water. Water, I know, helps me find it's a violent. Oh, now I can spell violent. Violent. Let me just go back to that. What's that violent reaction? Yes. I just can't spell today, guys. I was spelling violet, which is probably not what we want. Where is it? I don't have my glasses on. So that would be a violent reaction with the acid chloride. The litmus paper would be for amines. You'd expect blue. For acid chlorides and carboxylic acids, it would be red. So now I can start overlapping the information that I know because I'm identifying things. Bromine waters for the alkenes. And acidified permanganate is your oxidant. So that can help me find what am I thinking about? Alcohols, aldehydes. So you see how that annotation helps you kind of set up the answer for that? Other things to keep in mind is I want you to carry out descriptions of any test observations. I've marked a lot of people down because they've just forgot to include those observations, so don't miss out on that. The other thing is equations. Again, I've marked a lot of people down just because they have forgotten that. So double check that and watch yourself. So that's the whole kind of full answer of what we're looking at. You can see that they have an equation for each one. So in the acid chloride, just to show that it reacts with the water to make the carboxylic acid. In this case, with the amines, they're not actually showing it doing any reaction. It's just showing that when it's added to water, it makes a base. So, and the hydroxide ion, and thus explaining why the litmus paper is turning blue. So do kind of keep in mind, like, these are counted as equations. So don't forget the simple kind of like added to water equations. Cool. And then make some mentions. Think, again, always about solubility. So the moment that this alkene reacts and forms the dibromo, that's no longer water soluble. In fact, it wasn't water soluble to begin with, and so you're going to expect 2 layers. This adds to the layers of your answer. So, and that's what you're going to need for that excellence. So, or I should say, excellence or the E7, depending on how the marking schedule works out. So with the achieved, it's just choosing the correct reagent for 3 substances with incomplete observations, or you've gotten 2 substances correctly and you have 1 equation. Merit was 3 substances correctly identified with accurate observations, 2 equations, or all 5 substances identified correctly and 1 equation. But you see how you can see repeated throughout it. They want the observations, they want the equations. So if you forget to do those things, you're going to really limit your answer because it's actually built into the marking schedule. And then for the excellence, all chemicals are correctly identified with those observations and 2 equations. Remember, each time you give an equation, you increase your chances of getting it right. So even if you get it wrong, it's still better to put a guess down than to not put anything down because they didn't need all 5 equations. They only needed 2. So every single one, just put it in there as a nice little guess. All right, cool. And then the last question here, I might switch the document camera so we can look at it. And then we can go to the actual marking schedule. All right, so this one here is your ester question, and it's using that banana flavored, and they draw the ester out for you. Remember some things about esters. The breaking point is we're looking for the carbonyl and that single bonded oxygen. That's where it breaks. This component here is my alcohol. This component here is my carboxylic acid. Remember, carboxylic acid is your parent chain. The alcohol will be used as your branch if it comes to naming. They won't ask you to name something like this because if you can see, this is like a branch with a branch. So they won't expect you to name something like that because we haven't taught you those as the rules. But they could expect you to name the alcohol because you can do that one. So do kind of keep that in mind. Esters can be prepared by refluxing the reagents. We're going to underline refluxing because it's probably going to want me to use that in some part of my explanation. With small amounts of concentrated sulfuric acid. After refluxing, the mixture is treated with potassium carbonate and distilled. You need to, again, annotate it and think about why would they do that. So I see the word carbonate. That's probably for a neutralization. So make these notes while you're looking at it, so that way you can remember what are these things used for. So I know I need so that neutralization is probably to neutralize the sulfuric acid that was used. It's probably also to neutralize any excess carboxylic acid that was used. Distillation, we know, is a process to purify it, and so that's what I need to be thinking about. Cool. Discuss the preparation of the ester shown above. Your answer should include, again, chemical equations regarding it, so you're probably going to have to write the 2 reactants. The reasons for using the chemicals stated above in bold. So why do we need the sulfuric acid? Why do we need the potassium carbonate? And then discussion why reflux and distillation are used in the preparation status. Remember, be mindful what's the difference. Reflux has that tube that you are, in both cases you're boiling and we're getting evaporation. A reflux tube traps it and has it go back down, and a distillation tube instead allows it to separate and be removed. So reflux ensures 100% reaction, so I can write that down. and distillation is allowed for purification. Running out of space. Are we good so far with that? So really helps when you annotate it because it just helps you organize what to kind of put into your answer and what kind of hints they give you. I'm going to go back to the marking schedule so you guys can see that and see how the points were distributed around. Be mindful when you guys are doing this equation for ester formation or amide formation. It is a condensation reaction. We are producing water. Make sure water is in that equation as your byproduct because remember when we're making those, we're removing an OH from the carboxylic acid and the hydrogen from the alcohol. All right, 3 achieved points here. Describes the use of one reagent. So take a guess, even if you don't know what it's for. If you take a guess, you had a 50-50 chance of getting something maybe. A brief description of refluxing or distillation. Again, just take a chance and do it for both of them because that's 2 opportunities to get that achieved point. And then the last one is writes an equation, not words, for the reaction shown in the structure of the 2 reactants. So in that case, again, that was given to you because they gave you the drawing of the ester. So if you had just taken a guess and like broke apart that ester, that would have hopefully given you some points too. All right, for the merit was explanations for both reagents. For the merit also was the explanation for distillation and reflux. So again, it's worthwhile writing both of them down because if you get them both right, you get a merit point. If you get one wrong, then you at least get an achieved point. All right, don't leave anything blank. All right, and then the chemical equation is what you also needed for that merit. The excellence is basically a nice, neat answer with all the different things we're looking at. So the appropriate equation, look, right there, including that water. All right, don't forget that. That's a silly mistake that's going to drop you from an excellence point to a merit point. And discusses why you have the 2 reagents and why you're using reflux and distillation. Basically, the excellence point is all of the merit points. Cool? So don't do something silly and forget the water, because instead of getting your excellence point, you're going to get 3 merit points. Okay? Let me just scroll down and show you how the points broke down. So that's what it looks like for the different points. Again, you see that E7, 2 excellence point with a minor omission. So that's really going to bite some of you guys in the butt if you're forgetting little details. So that's why I keep kind of nagging you on it. Are there any questions about this question? Yes, Elizabeth. Yeah, so if we look up here, the sulfuric acid is a catalyst and or dehydrating agent because that's going to help remove the water and drive the reaction towards the product of the ester because it's going to be able to remove that mole of water. The potassium carbonate is the key there. That is a base, and that's to neutralize any excess acid. So if you forgot to do that, or let's say you forgot to tell me what the sulfuric acid is used for, again, that's going to drop you down to the merit points instead of having that full excellence point. It's pretty harsh marking schedule, this one. Anything else? All right. So hand in that CPR quiz so I can use that as potential evidence. Feel free to grab yourself a little prize. If you were working on something else and it's finished, hand it in to me. If it's not finished, feel free to take it home and keep working on it. I can collect it tomorrow. Yeah. Yeah, just whatever you don't finish in class, do at home. Whatever you finish at home, regardless of what day you finish it on, just drop it in my box. I will take literally anything. Does that sound like a good plan? Okay. I figured it's better to give you more paper than less paper. And if you don't use it, then it just ends up in the bottom of the pile. You could also use it after mock exams for revision. All right? Cool. Hand in anything that you have. Give me back my markers and things like that. And that's everything.